with and how well it pays off. I think it's time to bring in Aaron. He's our next speaker. See you, Lars. Hey, Aaron.
Bye, Lars. Bye, Lars. We say bye, Lars. And this is where we go. Wait, am I on mute? Am I on mute? Can you hear me?
Yeah, you're here. You're here.
No, I was pretty sure I didn't have myself muted this time. So, yes, fingers crossed.
Yeah, we've got to
that we
check
have
all the buttons.
Everything all good. Yes, I got to hit all the buttons on the stream deck and make sure everything's working.
Now, cool. So you're talking to us today about type-safe GraphQL with TypeScript.
That's right.
And I'm reading the abstract here, and it sounds really cool. So there's code generation. You're going to looking at how to have efficient storage and a whole bunch of cool stuff. You're looking at the schema, combining schemas. Oh, wow. Sounds interesting.
Yes. Hopefully. We've only got an hour, which seems like a long time, but we know how quickly an hour can go past when we're presenting, don't we? Yeah. Yeah,
no, it does fly. Look, good luck, and I'm keen to listen to all of what you have to say today. So the show is all yours.
Excellent. Well, thank you, everyone who is joining in on the stream and watching from wherever you are around the world. Hopefully you are watching the right session. This is TypeScript and GraphQL. We're going to be looking at how to use those together and how we can build type-safe applications. For those of you that I haven't had a chance to meet before or we haven't seen each other at an in-person event, which I miss them. I really miss in-person events. We'll get back there soon. My name's Aaron Powell, and I work for Microsoft, part of the cloud advocacy team. I've been doing web development for, I'm gonna say like 17 years now. I don't know. It's to that point where I'm just like, do I need to keep counting? I don't really want to keep counting because it's getting long, and I feel old when I say things like that, particularly to people that I'm coaching, mentoring that are just coming into the industry. But in that time, I've been able to work with a lot of different aspects of web development. I've built applications that were like truly server-centric, where we were doing things like everything was on the server. You would always send the whole page back, kind of web forms and predating ASP.NET web forms, to API-centered applications where we were building custom APIs to expose data out to the consuming clients, to REST-designed applications. And more recently, I've been looking at GraphQL and the role that it can play in the way that we build applications. If you want to reach out to me after this session, if there's a question I don't get to answering in the time or anything like that, you can find me on social media. You can find me on my email address there. I'll also be, I'm going to try and get into Gathertown at lunchtime. I'm actually going on a long weekend away because we're finally allowed to leave our houses here in Sydney. So I will try and jump in for a little bit in between packing the car to head out this afternoon. But do reach out because I want to make sure that anything that you want to know, I can help you get answered. But that's enough about me and all that kind of stuff. You're here to learn about application design and particularly about GraphQL. But before we get into building an application and things like that, I want to make sure that we're all on the same page of what we're trying to do. So we're going to build a game today. This is a game that I built back when we first started doing the lockdowns, and the only way that we were interacting with our friends was via a video call where we were playing like trivia and stuff like that. So I was like, well, how do we build a trivia game? So let's start with the data model for that, because this is the fundamental constructs that we're going to work with is the underlying data set. So we're going to have a quiz or a game object that is represented with a couple of fields on that. So we've got an ID, so we can uniquely identify games. We'll have players. A game will have a state, like are we waiting for players to join? Is the game in progress or has the game completed? We're going to have questions that are associated with the game, and we're going to have answers that players are providing to those questions. So then we end up with a relationship to a player's object, and that might have like the name of the player. Maybe we have some more information that we're storing about the player, maybe not. But then on that, we could we also have kind of a two-way relationship between those data models. We can go from players back to the games, and we can go from the games through to the players. And then, of course, we're going to have questions. So these are our three primary data models, and it's going to have the name, like the question that's being asked, all the answers that are available for that, because this is multiple choice, and then the correct answer that a player that needs to provide to get a passing point for that game. Now, this is it's a fairly basic data model, but we've got some relationships here, and as a result, it could be there's a number of ways that we can represent this out in the way that we consume it. So let's start by talking about REST. I know this is a GraphQL talk, but I want to contextualize things about REST because that's what we've done a lot of API development over the last N number of years. And this is the way that I would model this in a very strict REST sense. So we have our primary routes that represent the data models. And then from those, we would either get back like all the quizzes or a quiz by its ID, all the players or a player by their ID, all the questions or a specific question. And let's just think about the scenario where you're trying to display the completed game screen. So for that, we're going to need to know the game ID. We're going to need to know what questions were asked in that. We're going to need to know the answers, and we're going to need to know the players, and we're going to need to know the players and their answers. And in a very strict REST design, we'll end up with a lot of links that we end up having to follow. So we get back that first game from our quiz endpoint, and then that's going to have back a bunch of links through to the players and the questions. So then we're going to fetch to the players, and we're going to fetch to the questions, but we're also getting back data that we may not need. We don't need all the answers necessarily on the completed screen. We just need the correct answer so that we know if the player provided the correct answer when they submitted their response through the question. And this is where REST can have some challenges in the way that a client will want to communicate with it. And then this is where GraphQL comes at a different approach to the way we can do client-server communication in data modeling. So first off, GraphQL isn't a server, it isn't a client. GraphQL is a query language. We have GraphQL servers that implement a consumer of the query language and can process that query language, break it down, and then provide that through to your database and provide queries against your database. You can have clients that will construct GraphQL queries that can be sent to servers to process and things like that. But at the end of the day, GraphQL is a query language. It was originally developed by Facebook. It was built by Facebook to solve problems that Facebook has. So something to bear in mind is that GraphQL is not going to be right for every single project that you build because it was designed for a very niche set of problems that Facebook has. It's evolved since then, or do I need to call it Meta now? No, I think we'll still call it Facebook. It's very much evolved from what the original problem that Facebook was trying to solve, so it's a bit more general purpose, but it's like I said, it's not going to be for everything. Facebook has since open sourced it. They've handed it over to the GraphQL Foundation and they manage the evolution of the GraphQL language. So then what makes GraphQL really different to doing a REST API design is that you end up with a full view of the data schema that's available for your from your backend system, from your servers. And by having this full schema view, you can then work out what you need at what point in time as a querying client. So this means that, let's say, back to that scenario where I want to show the completed game screen. Well, for that, I'm going to say I want here's the game ID, and then I want players, and I want maybe the player name because I don't need any other information about players. I need the game answers, and I need to know whether what the answer that the player provided. I need to know the questions, the question that was like the description of the question, and then the correct answer. And I can do that in one single request. But I can also drop off the fields that I don't need. So this avoids an overfetching scenario where we're getting more data than we actually need at the client, which can be optimized then for maybe lower bandwidth available clients like Lars when he's stuck out in rural Australia, or mobile devices that don't have maybe the processing power to deal with exceptionally large data models. Now, there are other things that are useful about GraphQL that you can't do with REST, such as a subscriptions model, which allows you to do real-time communication via WebSockets. So in that case, a use case in context of this game would be you're waiting for players to join, and then you have a screen, and instead of having to do long polling saying, is everyone joined? Is everyone joined? Is everyone joined? You open WebSocket connections via subscriptions to your GraphQL server, and as a player joins, we drop a notification, send that back over the WebSocket so that all connected clients receive that information. So that's GraphQL in a nutshell. How does it look? Well, this is what a GraphQL query looks like. So this is a subset of a GraphQL schema. What I've got is I've hidden away a bunch of the type models and things like that. This is just the entry point, the way that you would query against the data structures that you've got within inside of your schema. So we get back a game by its ID, we can get back all the games, and we can get back the results for a particular player. Now, if you look at this, and it's kind of like JavaScript. Like you can see there's a JavaScript heritage in the way that this is designed, but it's not exactly JavaScript. I mean, there's types types don't exist to this degree in JavaScript, and the things like using the main operator, like there's no semicolons either. I'm very much a semicolon supporter in JavaScript, but that's kind of, you can see where that data model and that object model is kind of related back. So then when we perform a query against this, so we create a query. So this is the kind of thing that a client would be creating. We're saying that we're going to perform a query against a particular available query option within inside of our schema. We're going to pass that through, and then we're going to pick out the fields that we want back as a result. We'll see a bit more of this as we get into demos and start building our application. Now, realistically, you're going to need 4 core components to building an application with, well, basically any application. You're going to need somewhere to store the data, you're going to need some sort of infrastructure to run it on, and then you're going to have a client and a server that communicate together. We're really going to focus on the top 2 pieces of this, the client and the server. For this talk, obviously, I'm going to be using certain infrastructure and I'm going to be using certain data stores, but the stuff that I'm covering are not necessarily impactful for the way that you could build this application. So I want you to really focus more around the way the client and the server interact together. So let's just talk a bit about those components. So for the server, I'm going to be building it on Azure Functions. So I like using the serverless programmatic model. I find that quite nice, particularly from a price point for the sorts of applications that I'm building at the moment. And we're going to be using Apollo as the GraphQL server implementation. So Apollo is an open source project. They have a server implementation for GraphQL that runs on top of Azure Functions. It also runs across pretty much any common JavaScript web application framework. If you're using Express or Koa, like you can use it on side of there. It supports, I think, most of the other clouds and their serverless programmatic models and things like that. So again, the infrastructure here is not important, but I have to have some sort of infrastructure underpinning this. From a client standpoint, I'm going to be building it in React because, well, it's a Facebook heritage language. So I also prefer React. That's my kind of go-to web framework. But the stuff, again, that I'll show you from a client standpoint is applicable whether you're doing Vue or Svelte or Angular or like vanilla JavaScript without a web framework. Like, is that doable? Do people still do that? Anyway, that's going to be my choice. And again, you can swap all these components out. It's not going to be hopefully impactful. But what is the problem that we're ultimately trying to solve? Well, GraphQL is a type-based schema that is exposing our servers' data out to consuming clients. So it's got a type system within it. We define types, we can define enums, we can define interfaces, we can define custom scalar values and things like that. But then I'm going to be building this as a TypeScript application, and TypeScript has its own type system. So we're going to be talking to a database. We're going to have data models that represents the way the data is stored in our database. We then need to kind of communicate with our pseudo ORM that we've got in there, and then we need to expose that back out as a JavaScript application. But we've got 2 independent type systems now within inside of our application. We have the type system that's represented within inside of our GraphQL schema, and we have the type system that's represented within inside of our TypeScript application. They're not necessarily compatible because we don't want our underlying data structures exposed in their kind of rawness to our connected clients. But we kind of want something that helps us along the way. Like I don't want to add a field to my GraphQL schema and then have it explode in the data access because we didn't know that field existed, or kind of move things around. What does it actually look like at code? Well, on the left here, we have a subset of the GraphQL schema, and the one that we're actually going to build through our demos today. And you can see that kind of looks TypeScript type definition E. Like, it's not exactly the same, but you can see the analogies there. We see there's enums, we have types. Those types have fields and types against them and all that sort of stuff. And then on the right, we have our resolvers, the things that are going to handle the requests that have come into the server that are then going to work with our underlying data store. They're going to probably want to know about the type system that's there so that things don't explode. So how do we go about generating these types? Well, there's 2 ways that we can do strongly typed GraphQL applications with TypeScript. The first is to go down a schema first model. So in this, we have the types within inside of our schema, and they kind of look like our Javas or our TypeScript primitives. So I like this because it gives me a clean separation between the types that I'm making available to consumers and the types that are actually downstream within inside of my backend aspects of the application. And I don't necessarily bleed out the internal implementations. So I'm going to be using a tool called GraphQL Code Generator that will take the schema and generate some TypeScript types, and then we can use those to do to have some type safety between the way our resolvers work and the data that we need to expose out. So we're actually going to go schema first in the demo that we'll get to in just a few minutes. The other option is you could go code first. So code first is where we use our TypeScript objects that we're creating, and we annotate them in a way that we can extract the type definitions to create our GraphQL schema. So that's why it's code first. We start with the TypeScript objects and we turn them into a GraphQL schema. Now this gives you a clear relationship between the types that we've got within inside of our application and the way that we want those exposed out to our client. Now, if you want to go down this route, check out typegraphql.com, and that is a project that will help you do that. Like I said, we're going to be going schema first in the application we're building because that's my preference, and that's the model that I prefer to tackle. But that's enough slides, at least for the time being. Let's jump over to VS Code and have a bit of a look around at building an application. So here we are in my VS Code instance, and I'll share the links out to the Git repo that we're going to be working with. It's publicly available up on my GitHub at github.com/aaronpowell/GraphQL TypeScript workshop. Like I said, the link is at the end, and this is a workshop we'll go through building from kind of zero to hero in building a GraphQL application. So we're going to start from the start. I've pre-scaffolded with some useful things that you're going to want with inside of your application. It does have the starting for the React app, but we're not going to get to that till quite late in the piece. We have our API, which is where the Azure Functions is running. And it's got, this also has a dev container, so it's running inside of a Dockerized sandbox. If you're using VS Code remote containers, or if you're using code spaces on GitHub, you can use it with inside of that. But the first thing we need to do is we're going to need to install some npm packages. So I'm coming to the API folder and we'll do npm install, and we'll do, we're going to need the Apollo server Azure, and that's not how you spell server. Funnily, I actually did that when I was doing my dry runs. I kept typing Apollo server. Not sure what that's telling me about my brain. Azure functions, and we're going to function. That's not how you spell functions. And then we're going to need GraphQL, and I'm just going to pin this at the version 15 of GraphQL because version 16 of the GraphQL library has actually come out, and it has some incompatible types with the Apollo server implementations. They haven't upgraded to GraphQL 16 as an npm package. Okay, so those are installed, and I'm going to use Azure Functions to generate a new. Let's see, I might have it back here. No, I don't. We're going to use Azure Functions to generate a new template, and we will use HTTP trigger, and we'll call that with a name of GraphQL. So we'll generate a GraphQL Azure function that we'll now find within inside of our Explorer. Excellent, there we go. So obviously this doesn't have anything GraphQL in it yet. We will get to that in a moment. But one thing that we do have to change for Azure Functions is the output binding for HTTP trigger. It needs to become it needs to be $return. That's just for Apollo because it doesn't know what you've named the output binding that you've got with inside of your function.json file. So you just have to, so it will return from the function handler. So you just need to tell Azure Functions to look at the return value, not wait for it to be set onto a specific binding. Okay, and to speed things up, I am going to copy and paste some code that I wrote in the README. So this is a super basic GraphQL server that we will do npm start. We'll get that running while I explain what this code is doing. So in this super basic server, we are importing the Azure Functions package. We are importing GQL, which is a template literal to define a GraphQL schema. It has a single type. Cool. Our server is up and running. Called query. It has a an operation that we can perform on that query called hello, and that's just going to return us a string. And we have a resolver down here that is then the thing that is going to handle that request. So it matches the schema structure. So we have query, hello, and then it's returning a string. We provide that to Azure server, Apollo server, the type definition, so our GraphQL schema, our resolvers, and then we create a handler that Azure Functions can consume. So that's up and running. Let's pop this into the browser. There we go. And we'll come across to Apollo Studio. Zoom in a few steps. Let's resize our windows a little bit and delete the sample that I played with. So Apollo Studio is this is a sandbox application that allows you to inspect GraphQL queries, inspect GraphQL servers, interact with them, test them out, that kind of stuff. We can see that we have a root type of query, so that's the entry point on our schema. It has a field called hello, which I can add to a query, hit run, and ta-da! We have created our very first GraphQL server fully in TypeScript, but at the moment it's pretty simplistic. Like, we're not really caring anything about type safety or anything, that sort of stuff. I just wanted to prove that we can make a GraphQL server work, and we've done that. Time to go home. Wait, I'm already at home. You're going to be stuck with a lot of terrible jokes as well, because I don't get audience feedback, so I don't know if you're laughing or just cry laughing with me. So let's jump forward in time to the next point with inside of our workshop, just so I don't run off script and break anything. As I said, this does go through, there's like 8 steps. We are going to skip some of the steps because it's about a half-day workshop, and I only have 39 minutes left according to my countdown timer. Maybe less, depending if they kick me off early. So we're still here. We've still got our schema written the same way, but let's start extracting that out into a separate file, because at the moment this schema is embedded within inside of this .ts file, which means it's inherently undiscoverable. Like, we don't know where that schema exists. So I'm going to create a new file, and we'll call this schema.graphql, and we will grab the type definition here. Done that. Cool. It's all formatted. Lovely. And now we can get rid of this. But how are we going to get those type definitions? We need to import them some way and kind of parse that schema and turn it into something that can be consumed by Apollo. I'm going to, again, install some npm packages. So to do that, I will sneakily copy and paste from my README file, and we will put them into the API folder. So that will go ahead. Also, if you do actually go through this workshop yourself and you install the VS Code plugins that I recommend we run in the dev container, I have this code tour, which is what these little icons here are on the side, which you can step through, and it will give you hints along the way of what to do at specific lines of the code base and stuff like that. So it's another way, so you don't have to kind of alt tab back and forth between this schema, this README file. And again, for speedness sake, I will copy and paste our updated server implementation. Let's get rid of the terminal. There we go. Okay, so what have we done? We've imported 3 new modules from a collection of packages called GraphQL Tools. We're importing one that will load our schema. We're doing this synchronously because of the way Azure Functions work. We kind of actually have to we have to read that before we return things. Return the handler. So it's a little bit clunky. It just means that, you're doing synchronous schema creation. We're then saying that we're going to be loading from a file and disk. This is because you can be importing a GraphQL schema from a number of different locations. If we were building maybe a GraphQL server that is then sitting sitting in front of a number of other GraphQL servers, we could be loading from a HTTP endpoint. So this is what we call GraphQL Federation, where you're bringing through a bunch of GraphQL servers and then exposing them as one unified GraphQL schema. But we're going to be loading from a file on disk, so we're using the GraphQL file loader. And then finally, we're using the schema tools to add the resolvers to the schema. So we still have our resolvers object here. We're going to load the schema, and just a bit of path messing around to go back and find that, because we're dealing with a compiled TypeScript output. We're going to load it from there. We're going to add the resolvers to it, provide it to Apollo server, and then everything should go nicely, and we should be able to do npm start again, and our application should continue to run or be rerun, given that it wasn't currently running. All right, give that a minute. Excellent. Looks like our API is back up. Come over here. We'll execute the query. And there we go. So everything's still working. We've done the first step. We've extracted things out into a separate location. So fantastic. We're starting to get going. All right. So the next thing we need to do is start building out a more realistic schema. The schema that we got here is pretty simplistic. So let's start building out the schema that's going to look that we're going to need to represent our game. Again, I'm going to cheat and bring in some of this stuff from my pre-written script. So we're going to start with, so we find our question. So we have the ID, and we're using a special scalar type within inside of the GraphQL language, which is ID, just indicating that it's a unique identifier. And the exclamation point indicates that this is going to be a strongly typed, a non-nullable field. So we know that we have to have a question, we have to have a correct answer. And then with the array here, I'm saying that you will always get an array of 0 or more items. And those items are going to be strings, and it will always be a string. It will never be a null or an undefined or anything like that. Okay, oh, where did my README go? I forgot to open that in a pinned banner. There we go. So we have our question. Let's create our game. Add our game in, we'll add our enum that represents game state. And what else do we need? We're going to need our player. Select that. Okay. And lastly, we'll have our player result. Let's pop that in. Save. We will just have to restart the server because while it's got a file system watcher, it's not watching for changes to the .graphql file. And let's have a look at now what our schema is exposed as to connected clients, such as the studio here. Oops. Okay, so we've had an error. Well, that's not what we want. We don't want things to explode immediately. We want to explode when I expect them to explode. No. So the reason it exploded is that the resolvers that we've got here, and this is where we're starting to lose some of this type information. The resolvers need to match kind of one-to-one, or the resolvers can't have things within inside of them that aren't within inside of your schema. And that's what this error message has said. We've defined a resolver to handle something called query, but our schema doesn't have anything that has query. Now, we didn't know that. Well, we didn't necessarily know that because, well, there's no type information to help us along the way. I know that if I delete that, Apollo will, if something doesn't exist in the schema, it won't kind of freak out. It will just, well, it shouldn't have freaked out. I don't have a root type. Well, I'll put in the thing. I was trying to be clever and like jump forward with inside of time, but we will put in, here we go. So we'll put in the query and then that should, oh no, we'll pop in the schema. That's the last piece that we need. Okay, and then we'll restart our server. Isn't live coding fun? Okay, so the reason it exploded was because it didn't know where the root was going to be for anyone that wants to come and query your GraphQL server. Because we hadn't defined any of that inside of our schema. Now that that's done, now we've defined a schema object that indicates that when you're performing a query, you're going to start, like the root query is going to be at this type called query, not game or anything else. But the problem is that, well, so our resolvers aren't there and we don't need them there yet. And if we reload that, well, now we'll see that things start looking a bit better. We'll see that we have our query root here. We could query for a game with a specific item. So I could perform that operation if I wanted. I could perform like a request for all games. Whoops, not game state. I wanted to get back, let's get back the ID of all games, and we don't need that variable there. So now I can perform that query and it's going to explode because we haven't written anything that will handle that. You can see in the error message there, it says cannot return null from a non-nullable field query.games. And that's because our type system within inside of our schema has forbidden us to return a null. And because we haven't implemented anything, we're implicitly returning null. So we're getting some type information, and we're getting that back from our server. We're getting it from the way we're performing queries, but we've lost any of that inside of our actual application. So again, we're going to jump forward a little bit in time, where we'll start writing out some of the resolvers. I'm going to skip over the data storage section itself, and instead we'll see the way that I've implemented data storage in the application. But let's just close off all the windows that I had open, because I don't want to give anyone a sneak peek at what we've got coming. So for data access, this workshop has an in-memory data store. So it literally is just an array of objects that are maintained in memory, and every time you restart the server, you'll lose all your game information. Or you can store it in a persistent way using Cosmos DB. Pick your poison. And I do have the instruction in the workshop which goes through both ways of setting up data access. But for data access, I've defined a number of different types that we have here. So we have a base kind of like a base type. It's not a class. It's just a base type called model, because everything is going to have an ID and a model type associated with it. The model type is just whether it's a question, an answer, a user answer, or a game. Useful for storing in Cosmos DB so that we can perform queries against that, and we can set up the data in there with the appropriate partition keys. We have our question model, which extends model with question, category, incorrect answers, correct answers, type, and difficulty. So the data set that I'm using here comes from Open Trivia API, and this is the way that they return their data structure. So I've just kind of mapped that through. This is what I want to store in my database. User model, we have our name, the identity provider, user roles, user details. So that this could be plugged into Azure Static Web Apps and use the authentication model there that gives us some information. We have our user answer, we have our game, and then we have our three data sources: game, user, and question that we can access. As I said, there's an in-memory implementation and a Cosmos DB implementation. We're going to use the in-memory one for the time being, and we can see that I create that here. It's an Apollo data context. It's a data source, and I've strongly typed an Apollo context, which just is a way that we represent data sources. And we'll see a bit more of that as we get to implementing type safety. But we have things like user, question, and game. So that's all being given over to Apollo. So when it starts, it will understand that we can access data, but now we need to do something with that. So inside of our resolvers, let's go and build that out. And I'll pop the schema here on the side. If I can remember the keyboard shortcut, which I can't, which is annoying. I've recently changed my keyboard, and my muscle memory in VS Code has drastically decreased because I was just so used to where keys were on my keyboard, and now keys aren't where they used to be on my keyboard. Yeah, I've gone like crazy split keyboard layout. But let's just move on from me complaining about my tools. Okay, so we need to implement something. Never mind. So I need to implement this this query type here. So we're going to have game, games, and player results. So let's start with games, because games is the easiest one to do. Now I know that we're going to so because I've worked with Apollo before, I know that the first argument to this is going to be the parent in the object hierarchy that's being returned from our server. I know that the second argument is going to be any arguments passed through to the query, or any variables. And the third argument is our Apollo context, which is where we get data sources. Data source. Ooh, I can't remember whether it's data source or data sources. And I don't have any type information. Like I'm losing the value of TypeScript here. Data sources, that's what it is. Data sources. Okay. And then we will return data sources dot games. I think it's games get game. Okay. So that's how we perform games. And let's just grab a bit of sample data that I've got. Oops, where was that? There it is. So this is just a sample game that we can use for testing. We'll embed that into our thing here, save, and we'll bring in basic type. Cool. Okay. And we'll go to API and npm start. Okay. So that let's hope that this comes up and running. Oops. Give it a moment. All right, looks like it's working. The server is up. So now we do have a game there. I should be able to query this and get games of, it must be called games. It must be called. So now we're starting to see where we're getting the problems of lack of type safety. Now TypeScript is great because it gives us that type safety. GraphQL is great because it gives us that type safety, but I don't like this data source isn't any because it doesn't understand anything about this. It knows it's obviously not, it's actually called game, not games. So I didn't know that because I didn't have any type support. I didn't know this until runtime. And anyone that's done enough JavaScript development will know that you can very easily end up with runtime problems. And there's a reason that that compiled languages or languages that have type checking in them as part of a compile step are quite valuable. But anyway, let's do that. And is that games? Games. Can I read null from non-nullable field query.games? Did I not restart the server properly? Oh no, it should have been let's get games, not get game. Of course. Okay, there we go. So now we've created, so fantastic. You've seen the problems that lack of type safety can bring. And some of those were manufactured errors and some of those were because I actually typed things incorrectly. But if we were to say kind of like flesh this out a bit more, so we could do game, and then again, we're going to ignore the first argument. We know that this receives an ID, and then we're going to have our data sources, and then that will need to be return data sources.game, game, and then we'll pass the ID into there. So now we can get back a game based off of a specific ID. So, but like, what is ID? Like, how do I know that it's called ID? I know it's there because I've got the schema open side by side. But this is getting a bit tedious and it's getting a bit frustrating. So let's jump forward again in time and have a look at how will we bring some of this type safety information in here. And I'm going to skip over the first step of generating types and look at the second aspect of it. So when it comes to generating types, because I'm going schema first, I'm using a tool called GraphQL Cogen. So GraphQL Code Generator is a tool where you'll provide it with your GraphQL schema, and it takes you have a number of plugins that you give to it, and it will give you some output for that. Let's take our GraphQL schema just to have a look at it in the browser, what it's doing. Oops. Okay. So what it's doing is it's creating a couple of things like some utility types, like a maybe type, an exact, a few things like that. But then we'll see that we have scalar values, so ID, string, boolean, int, float, and how they map through to TypeScript or JavaScript primitives. So ID is a string, string is unsurprisingly a string, boolean is a boolean, int is a number, and float is a number because floating points are difficult. We see that we have a question here, and we can see the fields that are mapping to that. And we see that's defined as arrays and so on and so forth. If I was to change, say, question to be nullable, now it's a maybe type, and we can see that it has that the question mark there indicating that this allows us to assign null in TypeScript. And kind of so on and so forth. So we like that's really useful for us. Now we can get type objects that represent our GraphQL schema, and we can generate this. So I've gone ahead and set that up with inside of this step of the application. I've installed GraphQL Cogen, and I've created the cogen.yaml file. And I'm generating two things here. I'm generating the TypeScript definitions, and I'm generating the TypeScript resolvers. So the reason that I'm generating the TypeScript resolvers additionally is so that I can come into my resolver object here, and then I can strongly type it. I can say that the resolvers is this object here. And it is, let's just npm run gen, because I think things are not quite right. Oh, whoops, coming to the API. npm run gen, generated type. Let's see. The type signature that I was looking at there wasn't quite right. There we go. So we can see that the query, as we were expecting there, we have game, which we know, and now that's got some type information. It knows that it doesn't have any arguments provided to it. Whereas if I hover over game, we can see, if I can get it, there we go. So it has game query arguments, and it's going to have a field called ID. We know that we need to return a game object from here, so on and so forth. But we still lack that data source. Like it doesn't have a type yet. So how do we go ahead and give that data source a type so that it's understood within inside of our application? Well, that's where we have the Apollo context. So I've created a strongly typed Apollo context here, data sources, user and game in question. And if we were to add that as a custom bit of model mapping, which I'll grab from here, put it into my YAML file, make sure I get the indents correctly because it's YAML and nothing says fun like white space significance, says the person that is a huge fan of F#. Okay, so what I've said here is there's a file called Apollo context, and inside of that is a type called Apollo context. And where you have the Apollo context, I want you to strongly type that. Awesome. Now data sources is strongly typed. We know that there's a property called games. It's called game, but we're getting another red squiggle. This time it is saying that, well, it's a very long error message that won't fit on the screen, but essentially I'm returning an array of model types asynchronously, but this expects a array of game, not game model. So how do we fix that problem? Well, we come back and we grab some more stuff out of my sample here, which is model mapping. So this tells the code generator that where you find types, map them between the internal type that I'm using for my backend system will map through to this type that is available from my GraphQL schema. So we run gen, and there we go. Success. npm start. All right, looks like I've got about 5 minutes left, so I'm going to be kind of powering on through a little bit here. Oh, whoops, I forgot to do npm install on something maybe. Or should I have? I should have actually looked at the error message. It was not what I thought it was. We'll pop through to here, and we are missing something there. Okay. npm start. So we'll get our server up and running, and then I'll jump through to the fully completed application because I don't think I'm going to have time to implement this with inside of the React application, but I can show you what that looks like and how we can do type safety all the way through to our connected client. But there is still one more thing that's possibly going to explode if I do this. So I get games, I want the questions of this game, and let's get the question and the correct answer and the answers. All right. And as predicted, this is exploded. The reason it's exploded is because it can't find a field called correct answer in the object model that we're returning. So why has that happened? Well, it's because if we think back to our database types, it's correct underscore answer, not correct answer in Pascal case. So like our type system is all there, it's all correct, it's all giving us this information, but we need to help it out and explain how to do some of the custom mapping. So for that, I can come into the right level here and we'll go question, wait, where am I? I'm at the wrong set of parentheses. And we're going to go question. So we can do, we can give some help to the way that Apollo will convert our backend data models into our output data models. So here we're going to receive a question model. If we have a look at that, we're going to receive the question model, and I need to return, well, I need to return that particular field of for our question, which we can do with return question.correct answer. Similarly, we can do that for answers because we don't have an answers property that we store in our database. We have correct answer and incorrect answers. So again, we're going to do question, oops, not qubit, question, and then we'll return. We're just going to randomize these so that we don't get the answers in a predictable order. This will be question.incorrect answers concat question.answer, correct answer. Okay, save that. Wait for the server to restart. Ta-da! Now we have helped with some additional model mapping to deal with some of the custom data structures, and everything is looking just the way that we want. We are getting data back. We are getting type information. We know that when we're mapping here that it's the database type. We know that the question is going to be expecting question types to return. We know that this is expecting a string out, whereas this is expecting an array of strings. So that's all given us kind of the things that we need. All right. And the last thing before William comes back and joins me for Q&A, because I think I can see some questions starting to pop in, is let's go to our fully completed application and have a look at how we bring this into the client as well. So loading that up, there we go. Okay, so the last thing that I need to do is I want to perform things. So I'm using React hooks here, but again, it's sort of immaterial. You could be using it with any way to talk with Apollo client back to your backend server. But I want to say, let's have a look at the completed game. I want to perform an operation. If I can find it here, where is it? Where is that one that I'm trying to perform? Okay, we'll start with create a game. So I want to create a new game. This is going to perform a mutation that's going to need us to send some data and get some data back. So this is the query that or the mutation operation that I want to perform. I want this strongly typed so that I know that I'm going to get back that string ID. Well, I can generate the types using GraphQL Code Gen that gives me this typed document node. So this is a thing that GraphQL clients in JavaScript can consume. This typed document node can be passed through to any query operator, which then gives me back a mutation function. And then because this is a React hook, it gives me back the values that will be updated from that React hook. So I know that I know that data, that's the thing that's coming back. It's going to be a create game mutation or a null or an undefined, depending on what state we're in. If we unpack that a bit more, create game is going to be a optional thing that can return from a game, but it's going to pick out just the ID field. So if we have a look at dot notation, we'll see that we have ID, which again matches the thing that we wanted, the operation that we've tried to perform against our GraphQL backend. It's all there as expected. And I think I'm just about out of time. So let's jump over back to our slides and quickly wrap up. If I can find my slides. Where did they go? There they are. Okay, so that was a lot of stuff to go through in a very short period of time, and yeah, so we wanted to leave some time for questions. Now, if you want to get if you want to have a play around with this workshop and have a look at the stuff that I didn't get time to dive into, you'll find it on my GitHub at github.com/aaronpowell/GraphQL TypeScript workshop. I'll also share these on social media and in the Slack channel with the NDC hashtag on Twitter. If you want to get them and you don't want to frantically try and screenshot or type them down. GraphQL Code Generator was the tool that I used to convert the GraphQL schema file into TypeScript type definitions. And if you want to learn more about using GraphQL and on Azure, I think it's a 7-part series so far of doing that. You'll find the starting point of that, of how we get started. We kind of build out a bunch of stuff that we've seen in the workshop today. And again, for the folks that are here in Australia, if you want to grab some Azure swag, the link is now working. Looks like we actually had a problem with it initially, but that is now working. So you can claim your Azure swag, or if you don't have an Azure account, you might have a free trial. Jump on there and use the Azure Pass to get ready to have a play around. But looks like William's about to join us again. So thanks everyone for sticking around. I hope that was interesting. I hope you've learned something new about how we can do GraphQL in a type-safe manner. Thanks for having me. So now over to questions. It's going to be really awkward if William doesn't come back. No, he is. Excellent.
Hey, that was really smooth. Hey, virtual cut.
Yeah, well, look, because we can't be there in person, I have to bring my own audience applause. I also have a laugh track, but I didn't use it because I didn't think my jokes were funny enough to warrant that.
You could have played it. It would have been quite funny, actually. Aaron, like I said, that's really smooth session. I'm actually was taking a lot of notes here. And there is a question that in the chat the one from Ben Lowbridge. So Ben's asking, is there a benefit to building out the application schema first as opposed to the types first?
So benefit is probably a subjective term because everyone has a view of what is beneficial in a different way. So the reason that I prefer to go schema first than database first is that tends to be the way that I think about designing my application. I think about what the client is going to be wanting before I think about how the data structures are going to be. Now, in my past time in consulting, I definitely worked on applications where we started database first, where we would design out a database structure and what was it going to look like for us to store the data and then turn that into an API that we're then exposing to our clients or into an application that was going to be consuming it or whatever it might be. So benefit is, like I said, it's a subjective term. There are going to be reasons that you would want to do it. There are going to be reasons why you wouldn't want to do it that way. But think about it in terms of what is going to be the best fit for yourselves, for the approach that you want to take in the way that you're designing your architecture. And then ultimately that should help you with the decision on, do you want to go schema first or do you want to go data modeling first?
Oh, that sounds good. Yeah, it is definitely a subjective. You, like I said, you get to a project and the database is already there, but for some reason they decide, hey, we need GraphQL. Now, you mentioned GraphQL, and you've done all the demos here with JavaScript, TypeScript, but what about all the other sort of platforms, other languages out there? So .NET, C#, F#. What do we do there?
Well, first off, I'd say why are they important? Just do everything in JavaScript. Nothing goes wrong with that.
Okay, sure.
Just as a complete segue, and something that I saw on Ignite's announcements was there is some updated support for Excel macros to be written in JavaScript. So JavaScript is taking over the world. You can write macros for Excel in JavaScript, but I digress.
Wow.
If you're, let's say that you're building a .NET application, there's a couple of different libraries out there that will do GraphQL servers for you. My pick of them is Hot Chocolate. Funny name, serious project, I guess. It's a very fully fledged GraphQL server implementation for .NET. It runs on ASP.NET. It can run on Azure Functions. Otherwise, there's GraphQL.NET. It's another project that's out there, another open source project. And in my GraphQL on Azure series, I actually talk both about GraphQL.NET and Hot Chocolate, and we look at how we can implement with either of them. In terms of how do you the data structures and things like that, GraphQL Cogen will actually generate you C# classes from a GraphQL schema. So if you are going down that schema first route and you want a way that you could generate your classes to maybe give to NDC framework or use as mapping between your NDC framework ORM and your resolvers, it can actually generate you that stuff as well. So you don't have to go down a code first route if that's not the way that you want to tackle it.
So that's the tool that you've used during the talk, right? The same one.
Yes, I think so.
Cool. I'm definitely going to explore that one a bit further myself. Got another question here about the schema. So it can be quite big. Let's say we've got a really complicated application. Can we split it up? Can we make it a little bit more manageable? What's any downsides to doing that?
Yeah, so if we think about some GraphQL servers that are out there, so GitHub has a GraphQL server component to it. So instead of using the REST API, you can use GraphQL, and there is hundreds of things you can do with GitHub's API. Now, I'm making some assumptions here. I don't actually know how the GitHub GraphQL schema is implemented, but I would expect that they're probably splitting it out as a bunch of separate schema files. Now, you can. Because you still need to expose this as a unified front, you can do that in a couple of ways. First is through federation, where we have something that will then bring together a bunch of schemas and then expose them out as a single unified view. The other is you can just take a schema within inside of an application and split it out over multiple files and use GraphQL tools. So what I was using for loading the schema from a file and then converting it into something that Apollo could consume, they also have a plugin that is used to kind of extend the GraphQL language a little bit, that allows you to write basically an import statement. So you could have the types for your game and your player and your question as separate things inside of separate files, and then you can use it to just bring them all into a single file that is then the thing that you're serving out. So that can be like, if it's maybe a project that doesn't warrant you creating a bunch of different microservices that are all exposed to GraphQL, but instead you want to just avoid having one file that's like hundreds and hundreds of lines of GraphQL schema, you can use that to merge them all into a single file and then expose it in a single server.
Cool. No, that sounds great. I've got just a sort of an obvious question. When does GraphQL go wrong, or what's the sort of pain that you may have encountered before for others to be aware of?
Yep. So probably the number one biggest thing that I find painful with GraphQL is authentication. Because GraphQL is a query language and it's pretty expressive in the way that you can represent it, but it doesn't have a good way to represent authentication and authorization access. Because you are kind of giving someone the power to get very close to your underlying data models and query against those, how do you do authorization against that? So how do you make sure that, well, like I might have access because I'm authenticated to perform this particular query, but do I have access to that field within the database, or that that other data model that's following a relationship? How do you implement that? So that can be a difficult thing to do, because first off, you need to make sure you're modeling it out for your clients to consume and understand the things they can and can't do. But also you've got to have your resolvers intelligent enough that they can deal with that. Probably the other thing is that GraphQL is very well known for allowing you to create your own like DDoS attack against your own infrastructure. So this is actually possible with inside of the schema design that I have in that GraphQL query. You can go from a game to a player, back to a game, back to a player, back to a game, back to a player, back to a game, back to a... So you can end up with this object graph that just gets huge. Wow. And if you haven't implemented your resolvers to be intelligent enough to perform short circuits or to detect recursive queries and things like that, you can very quickly create your own DDoS, because you've got a query that is just recursing on itself. And if you're talking to a database, you're building a query that's going to the database, that's then it's building a new query that's going to the database, that's building a new query, and that's just a limitation that you've got in the way the language is designed. Now, there are ways around that. Like I said, you can have your resolvers intelligent to detect short circuits. There are projects out there that will enforce those short circuitings with inside of resolver chains. So you can't go more than like 10 deep in field traversals. Or you can just hope no one realizes that they can bring down your infrastructure by writing a very poor query.
So I was just thinking, even like what you said, that DDoS attack, so that is when you write the query, so you're just nesting the same types over and over, deeper and deeper, right? So you get a very wide, a very deep sort of query, and that creates that DDoS headache. Oh dear. Cool. And I guess even if I think about subscriptions, can you, somehow you can sort of exhaust WebSockets as well if you want to subscribe to literally everything, or is that not really a problem anymore?
Well, no, it's definitely a problem. And the other challenge with subscriptions and WebSockets in general is that you end up with a very tight coupling between client to server. So scalability becomes a problem. So if we think about a cloud infrastructure where we're scaling out, we've hit a scale limit and we want to add more infrastructure to it, or we want to scale up the size of our infrastructure, more CPUs, more RAM. Well, how do we maintain those socket connections across scale ups? Also, WebSockets don't work in a serverless model because they're kind of like anti-serverless. Like the point of serverless is that it's event-driven. And then if you're like, I want a persistent connection, well, how are you having a persistent connection to something that is inherently not allowed to persist? So you definitely can, and you can definitely overload a system using WebSockets and using the subscription model, mostly because it limits the ability to scale.
Cool. So in a sense, really, we have to make sure that we're picking the right tool for the job. It's built for purpose, and if things change down the track, then we have to be mindful of that. We don't want to create a really big problem. Well, that looks like all the questions I have, Aaron. So thank you very much. Great talk. I think Lars is burning to come back on screen. He's got something cool in store for us coming up. Are you there, Lars?